All right, welcome to the very first video of the very first unit of Pre-Calculus 12A. All right, what a great time that we're going to have today. So first of all, had to look for a place in the school to do some recording, and the only place I could find was the third floor science book room. It's this tiny little closet, and here I am just locked away in it. So if somebody happens to come in and get a book, probably have some explaining to do. Why is this guy in a closet? Well, anyway, moving on. Okay, we're just gonna get started, and we'll deal with that situation if it happens. We're doing some transformations of functions right now, and that is the first unit of this course. And this basically lays down the foundation for all of the pre-calculus and calculus courses in grade 12. You're going to see the major concepts of this unit for pretty much every unit that you do in grade 12 math. All right, so it's going to come up over and over again. So we're essentially laying down the building blocks of this grade 12 math house that we're going to build and have finished by the end of your grade 12 year. So anyway, enough said about that. Let's take a look at transformations of functions. We're going to take a look at what happens when we do a number of things to graphs. We have translations, stretches, and reflections. We are going to focus on translations today. Translations is when you shift a graph, and they can be horizontal or vertical shifts. So you can move a graph to the left or right. You can move it up or down. It's the exact same function, same graph, except that it's now relocated to another area of your XY plane. So what you can see down here, okay, is you just see visually, there's no equations or anything, but you can see visually on the very left, on the bottom, we have a parabola, and on the right, on the bottom, that same parabola has been moved 3 units to the right. So we literally just take that parabola and shift it to the right 3 units. So of course, if you move left or right, you have a horizontal translation. If you move up or down, you have a vertical translation. We don't do any other like diagonal translations or anything like that. But when you state your translation, you should have a direction, left or right, up or down. And it should also give you the number of units that you're moving. So like 3 units to the right in this case. Some other translations could be 2 units up, 4 units to the left, that sort of thing. So a number of units and a direction. And your direction will either be horizontal or vertical. So what we're going to do, okay, we're not actually going to be taking a look at some parabolas in this unit. Okay, we're going to stay away from parabolas for the most part. But just to put this in a context of things that you've learned in previous years, let's take a look at some translations. You've kind of already have done those in the past. We have a parabola on the very left side here, the most basic parabola you can do with a vertex at 0, 0, just a basic y is equal to x squared graph, and we have a table of values as well. And what you can see is that if we have an equation where it's still a parabola, it's still x squared on the right, but it's x minus 1 all squared, what that minus 1 does is it actually has the effect of moving the graph to the right. You can see that in the visual representation on the bottom, you can see that the graph moves 1 unit to the right when you have x minus 1. So if you had x minus 2, it would move 2 units to the right and so on. Just to expand on that, okay, if you look at the equations on top there, the y equals x squared, the basic parabola, and then you look at the new equation I have on the right, I think you've already learned how to identify the vertex of a parabola in grade 11 foundations, right? You would take the opposite of what comes after the x, so the x minus 1, that is a positive 1, and then you keep the y coordinate at the end, the positive 2, so the vertex is going to be positive 1, positive 2, and you've done that before. But you never really thought about this in terms of translations, and that's exactly what's happening here. Okay, you can see that the parabola on the left, to create the parabola on the right, what you do is you move that 1 unit to the right, that comes from the x minus 1, and you move it up 2 units. So it now has a vertex of 1, 2. And you can consider that to be translations. So we have a horizontal translation. We do a lot of abbreviations here, so you're going to see that written as HT. HT is a horizontal translation. And you can see horizontally, left or right, you can see that it's moved 1 unit to the right. And then vertically, you can see it's moved 2 units. Well, I have 2 units right. That's wrong, okay? Look at me giving you some false information here, okay? Vertical is definitely up or down, so we're going to say 2 units up. So once again, we identify each translation with a number of units and a direction, meaning left or right, up or down. Now finally, okay, what I'm going to do right here is you do not have to write any of these down. We're just going to experiment a little bit here on Desmos. Okay, we can see that your basic parabola looks something like this right here, y equals x squared. And we already know what if we make a new parabola equation, just creating something off the top of my head here, x minus 3 squared plus 4, you can see that that has the effect of shifting the graph 3 units to the right and up 4 units. So your horizontal translation is 3 units right. Your vertical translation is 4 units up. A number and a direction for each of those translations. And you can get that from the equation. You get the horizontal translation. It's the opposite of what comes after x. Your vertical translation is what is at the very end.